So this is going to be our first activity on constructions. Step one, please take the sheet that we folded up into fourths and let's label them so that the upper left-hand quadrant is number 1. The second one is on the right. The third one is below it. The fourth one is on the bottom right of our front page. Flip it over, upper left is number 5, then 6. And the bottom of the page is number 7 for the whole bottom of the page. There is no number 8. And this is the tool we're playing with. This particular one is called a bow compass. And a bow compass is called that because it has a specific set of features that allow you to adjust the size using this little wheel here. So you'll notice if I pull the wheel down towards me, the ends get wider apart. Don't pull it so far that it pops off the end of these screws. That will break it. You can move it the other way and it begins to pinch down. Again, please don't ever pinch it manually or spread it apart. This is another form of compass. I don't recommend this style of compass. It can be tightened using this little screw feature here, but it doesn't hold a distance very consistently. This will. Now, we're going to use this for what it's good for. It's to draw circles. So number 1, I want to draw circles. The way I'm going to do that is, first of all, I'm going to stick this needle part into my paper and hope that it stays there. If I'm just holding this paper on top of this hard desk, it's not going to stay there. It's going to move around all over the place. So you should put something under this page that we're drawing on, whether it's a stack of papers, a binder, your homework, a book. Put something soft underneath it so that when you take this needle part and stick it in, it sticks in and holds to something. What I want you to do is stick it here basically in the middle and then tilt the pencil part down, pinch the top with your 2 fingers and twist. And you should get a circle. If you then adjust the size of your compass to be slightly larger and try to return it to the same hole you poked in the paper. If you didn't poke a hole in the paper, you weren't pushing hard enough into some paper below. And try to make another circle. These 2 circles happen to share the same center. Because they share the same center, they're called what kind of circles? Concentric circles. Con means with in Latin, center. But I want you to play in this first little region. I want you to make as many circles as you can. Well, not true. I want you to make good circles. So change the size, put it in different places. See what you can do about making interesting shapes, pretty circles. The objective is to demonstrate that you can draw circles. Yeah. Here, bring it over here to me. Yep. Well, right now you've got this thing way too high. Yeah. So we can adjust that. I'm just going to cut off a little bit of your lead. And that should be okay. Mm-hmm. I have a compass, but it doesn't have a pencil part. Doesn't have a pencil part. Is it the kind where you put a pencil into it?
No, it's just like 2 pointy ends.
Oh, yeah, no, that's not going to fly. That's actually called a plotter. It's for sailing. Doesn't do the same thing as this. Oops. Okay. Yep. All right. Have we successfully drawn circles? It's challenging, isn't it? This is a new skill. What I'm telling you is if you can't draw circles, the rest of this will be very challenging. So check with your neighbors, make sure that they can help you draw circles if you need to. All right. Number 2, we are going to copy a segment. In order to copy a segment, we should begin with a segment of some sort. So please take your straight edge and draw yourself a segment, not too long. And let's label it AB. Now we want to copy this segment. There are 2 critical parts to this segment. What are they?
A, B.
Yeah, the distance between A, B, that's one critical part, is that it's a fixed length. What else is true about every single segment? They have endpoints, true, that determines the length. They do a midpoint. It's straight, isn't it? It's not wavy or curly. It's part of a line. So we're going to get that straight part taken care of first. Take your straight edge, and I want you to draw a segment that is definitely too long. Can you agree that mine is too long? Okay. So what I'm going to do is I'm going to copy this point A, and I'll put it on the front of this new segment. Because this is a copy of A, I'm going to write A with a little slanted 1 exponent kind of thing. Looks kind of like an apostrophe, but it's not a comma shape. It's a straight piece. And we label that as A prime. That's what that point is now called. Prime means it's a copy of the original. Begging the question, who was Optimus? Just leave that hanging out there. Okay, so we now need to find B prime. So what I'm going to do is I'm going to use my compass. I'm going to take the needle part and I'm going to sink it right into A. And I'm going to open this up using my wheel carefully until I get to B. In other words, I want to measure the distance from A to B using my compass. And I'm going to make a little mark there on my page. Doesn't show through very well. Let's see. Right? I'm demonstrating that I've pulled it from there. And then I'm not going to touch my compass. I'm going to keep it the same size. And I'm going to move it down to A prime and make a mark. And what do you think I'll call this mark? B prime. And we've successfully copied the segment AB. Now we can create a congruence statement or an equality equation to describe that these are the same. We could say that the length from A to B is the same as the length from A prime to B prime. But that doesn't really say it's a copy of the segment, it just says they're the same length. So a stronger thing to say would be that the object, segment AB, is in every way congruent to the segment A prime, B prime. And notice that this notation is critical. When I use the congruence symbol, I have to be talking about the whole objects, not just their measures. Any questions on copying a segment? If you wish to annotate this stuff so it's easy for you to remember, sometimes what people will do is they'll say, this was my first step. This was my second step to name it A prime. Then I measured B, marked it here, and then labeled it. If you wish to, you can annotate it this way to give yourself the steps required. All right, number 3, we're going to be doing segment addition. So we need to give ourselves 2 sort of short segments to begin with. Call it AB, slightly longer one, CD. Now, we're going to combine these 2 segments into one longer segment. So let's begin by giving ourselves a nice long segment. I'm going to make it diagonal, so it's definitely long enough. In concept, in the world of geometry, we float around in space. So the angle that I'm putting this at doesn't matter at all. What should I call the first point? A prime. And let's do exactly what we did a moment ago. Capture the length AB and put it right onto here to make B prime. Okay, and what are points? Locations in space, right? Do you ever look on your Apple Maps when you're tracking somebody and see that you and they have occupied the same space, your little overlapping icons? So what we're going to do now is we're going to make C right here in the same location as B prime. So this is C prime. Let's just do the same thing. Measure from C to D. Pick it up and move it down here to C prime, which was the same as B prime. And what do we call that point? D prime. Remember up here when we had one equation and one congruence? What should we do here? Can we do both of those? This is an oddity. We'll get to this discussion a little bit more on Friday, but we cannot add things in the world of congruence. Like if I give you a half-liter soda bottle and another half-liter soda bottle, and you add them together, does it magically morph into a full liter soda bottle? No. But if I were just looking at the volume in a half liter, plus the volume in another half liter, wouldn't that add up to the volume in a full liter? Yeah. So what we're going to say is we want the length AB plus the length CD to be equivalent to the length A prime D prime. We're just talking about their lengths. We're not going to try to add together the segments because if I added these 2 together, they wouldn't necessarily be in the same order. It wouldn't be on the same line. So it wouldn't say the same message. How are we doing? 5, I'm following along. I understand what we're doing. I feel good about this. 3, I'm keeping up. It's kind of fast paced. I'm not sure I could reproduce this, but it's giving me an intro. 1, I've fallen behind, I've lost my way, and I keep poking myself with this thing. It hurts. Good. Number 4, one of my favorite words, perpendicular. Perpendicular. This is a perpendicular bisector. And then we're going to say of a segment. So let's begin with a segment. We're going to make this one fairly long. Satya, why don't you name these points for us? I'm tired of using A and B. What do you want to use? XY, okay. All right, we're going to bisect XY with the segment that is perpendicular. Now, we know that if it bisects, at what point does it hit in this segment? Good, the midpoint. But it's imprecise for me to think that I could find exactly where that midpoint is. Is it like there? It would be hard to predict it exactly, wouldn't it? But do you feel comfortable that this is not the middle? Am I now going someplace that is clearly not the midpoint? I want you to set your compass to be more than halfway. It can be 3/4, it can be 4/5, it can be 16/17. Just make sure it's more than halfway and make an arc there. And try to make it almost a half circle. It's a pretty long arc. Once you've created it, pick your compass up, turn it 180 degrees so that your needle is now on point X, and make another arc of the same length, the same radius. And this little oblong shape I call a football. It's a poor representation of a football, but for our purposes, it's helpful because we see the end points here are points of intersection. And if we now connect those 2 points of intersection, the resulting segment does 2 things. It perfectly splits X and Y in half. So I'm going to use these marks to show that these 2 parts are the same. And it's perpendicular, makes a right angle.
How'd you know what it was?
I connected these yellow things that I marked, the points of intersection of the 2 arcs. They meet on the top, they meet on the bottom. Now, I'm kind of tired of writing all these points. How could I name this line with only one thing instead of 2 letters? Good. Lowercase cursive letter, like maybe L. Okay, good. So now what I can do is I can say L is perpendicular to XY. Should I make it a segment? Should I leave it with nothing on top? Should I make it a line? What goes on top of XY? Segment. Because the fact that well, it could go either way. Actually, this could be the line. But when I want to say L bisects XY, I have to make it the segment because a line is never bisected. It's infinitely long, so how could you cut it exactly in half? So L is perpendicular bisector to XY. All right, let's flip over to the backside. Number 5. We're going to copy an angle. This must be where they come up with copyright. Dunch. So let's give ourselves a little angle. That's a new one. I just made that joke up. I like that. So let's label this point Z, because we can. Now I want to copy this angle. Theoretically, these are rays, right? They go on forever. So I'm not going to be copying those like segments, but what's the important part? Like how far apart they are, right? Like how split they are. But what's weird is they're split a certain length here and a different length here and a different length here. But do we agree that they've all, no matter what angle I've got, it's going to have a ray for the bottom here? So let's give ourselves that free one. Let's come down here and just draw ourselves the first ray. First one's free. What should we call the vertex here? Z prime, because it's a copy of Z. Now again, because this mouth of the alligator, so to speak, is at different lengths, we need to establish a spot that we're going to copy the length from. So we're going to create what's called a reference arc. Take your compass and adjust it so it's pretty good sized, but so that if you anchor it on Z and you make an arc across the mouth of this thing, you'll hit both sides. We don't want to go so far that we miss one of the rays. Once you've made that arc, pick up your compass without adjusting its size and move down to Z prime and make the same arc. And exaggerate it a little bit, make it longer than it needs to be. And now what I'm going to do is measure exactly how far it is across this mouth. In other words, how long this arc is. And then I'll copy it down here, and that'll find where the other one is up here. And then I can connect it. So I'll take my compass and I'll anchor it on one point of intersection here and adjust my compass to go right through that point of intersection and make a mark to show that I've done that. Once I've done that, I pick it up and move it down here and copy that same thing to this one, to my new angle. Need me to show that again? Okay. So first I made a reference arc of any size, and I copied that same one down here. Then I came back, and after identifying where that arc hits these rays, I adjusted my compass so that it's just the right length to mark right through that point of intersection. And then I pick up that compass and move it down here and make a corresponding arc there. Now I'm going to connect Z prime through that point of intersection, and that should give me an angle that's the same measure. How do I express that these two angles are the same size? Well, I could put a little hash mark on them to say that they're the same size. I could even put like 2 marks here showing it's an angle and put the same 2 marks here showing it's an angle of the same size. Or I can state that the angles are the same. Is this unambiguous enough that I can call it angle Z instead of needing 3 letters? When I say Z, it's no question about which angle I'm talking about. There's only one here. So I could say angle Z is congruent to angle Z prime. Okay. We had success bisecting a segment. So let's step that up here. Let's do an angle bisector. Before we can bisect an angle, we need to have an angle to bisect. This angle is going to take up most of the space in this little quadrant. And let's label this one, let's go Q, R, S. And again, these are rays, so it doesn't matter how far it goes out. Can you classify this angle for me? Acute, good. I think it's less than right angle as well. So maybe it's like 80 degrees. So if I tried to bisect this angle, what would that look like? Would it be like this? No, it would come out of the vertex R in such a way that it exactly splits this angle in half to make 240 degrees, for example. So the way we'll do that with our compass is we're going to make a reference arc again. So anchor on R, make an arc. Mine happens to go through S, yours doesn't have to. You'll see that your arc meets each of the rays, right? It has points of intersection with both sides. So now what we're going to do is we're going to do a perpendicular bisector between those two endpoints. Treat it like it was that segment. So from this point of intersection, I'm going to go more than halfway. Do you agree that's more than halfway to the yellow one? It's like closer to the yellow than the middle, isn't it? And I'm going to make an arc. And your arc may fall outside of R. It could fall on R, although that's not best. And it can fall inside R. Then come back and use that same length from the other point of intersection and make the arc this way. Now we're going to look at those football ends again. And if I did this correctly, I should be able to line up both of those football ends with R so that all three are in this straight line. What do we call that? When 3 points are in a straight line? Those points are collinear, good. And if they don't appear collinear, then you made a mistake somewhere. It's like a nice check to make sure you didn't make a mistake. Let's create a point M on this thing. So what can we write to communicate what we've done? What is our angle bisector? What do we call this thing? M. I can't call it M. M's a point. R. Ray RM. Good. Ray RM. So I'm going to say RM ray bisects. What do we call the big angle? Good, QRS would work. Could I also say SRQ? Yes. Could I call it SQR? No. Then lightning would strike from the sky. I could also say that two angles are congruent. Because of what I've done here, which two angles are congruent? QRM and MRS. And when I'm talking about angles being congruent, what do I put in front of this? Little angle symbol. And I'm saying the objects are completely congruent. If I wanted to say that they have the same measure, I'd have to put a little m in front of it. Now I'm only talking about the numerical value, and it's the same as the measure for angle MRS. One last one. This one's the big guns. Number 7 is construct a hexagon. Let's even go a regular hexagon. How many sides does a hexagon have? Mine always have 6. Octagons have 8, right? Hexagon, 6. You'll notice that there's a height to this page we're looking at now. I want you to adjust your compass so it's just about a quarter of that height. Doesn't have to be precise. Go a little bigger, so I can go 1, 2, 3, 4. That looks about right. And then go right into the center point and make a circle. And don't change your compass width. You're going to leave that width for the entire operation here. Yeah.
Their motion sensitive. Water.
This is our last skill. Hang on, please. Okay. So what you're going to do is take your compass, which is the same size, and you're going to pick any point along the rim of this circle, any point you want. Set your needle into that point and draw an overlapping circle.
Should it be that same size?
Yes, must be the same size. Now, if our first circle was circle 1, and this is circle 2, do you see where 1 and 2 circles intersect? Okay, pick one of those points. There's 2 of them, right? Doesn't matter which one you pick. Pick one of them and make that the center of circle 3. Again, the same size. Now you'll see circle 3 meets circle 1 in some place. Set your compass at that point and make circle 4. Continue working around circle 1. Here's where circle 1 meets circle 4. Here's where circle 1 meets circle 5. Here's where circle 1 meets circle 6. You should have this pretty little flower.
think they're doing something nice to get lunch there. Oh, there's waterfall. If you connect the tips of your little flower, carefully with the straight edge, create a hexagon. The tips of the flowers have to go to the beach. What I'm passing on now is not stages, 2 pages each. I'm sorry about that. Printer family. For tonight, I'm passing out the Unit 1 study guide. Again, our unit test is coming 1 week from today, so you should start preparing for it. I do not need you to finish the study guide by next class. You do not need to finish it by next class. You'll have the weekend to keep working on it. Have some time on Friday. Those of you planning to do the retake activity, you might want to not plan to do too much of this in class because we have that. However, what you're turning in for tonight's homework is the drawings you just did of the construction. That's what you're submitting as tonight's homework. It's really only classwork. And then I'll have you turn in the unit study guide on Monday.